Hi girls, Mrs. Blaufuss again here. This is lesson 2.2 in your textbooks, and it's inductive reasoning. So far we've learned a lot about shapes, and we've drawn some conclusions, and we talked about points and lines and planes, and we're starting to draw pictures. But now we're going to start visualizing or continue visualizing things and see if we can come up with a common theme or a common pattern to make a guess as to what the next pattern is. So we're going to use a couple of new key terms, inductive reasoning and conjecture. And we're going to look a lot more at patterns. So on this first slide that you have in your guided note sheet, it asks you to look at those 4 figures that are already drawn for you, and then to sketch the next figure. So you'll have to think of what the pattern is between each of the figures, and then think of how many squares are going to be in the 50th figure. So take a minute and sketch the next figure, pause the video while you work, and then unpause for the solution. So in this first figure, we see 3 blocks. That's 1 dimension up by 3 blocks to the right. In the next one, we see dimensions 2 up and 4 over. In the third one, we see 15 blocks. That's 3 dimensions high, 3 blocks high, and 5 blocks to the right. And then in the next one, in the 4th figure, we see 4 blocks up and 6 blocks wide. So in our 5th one, let's add a row and add a column. So our 5th one is going to be 5 blocks high and 7 blocks wide. So it'll look something like this. So we'll have 35 blocks. 5 times 7 is 35. So we've got 1, 2, 3, 4, 5 blocks high. 1, 2, 3, 4, 5, 6, 7 wide. So that's 35 blocks. Well, what about in the 50th figure? So in the first one we have 1 high, the next one we have 2 high, the next one we have 3 high, 4 high, and 5 high. So in the 50th figure, we're going to have 50 blocks high by, in the first one we have 3, the second one we have 4, so that's 2 plus 2. The third one we have 5, that's 3 plus 2. The next one we have 6. The fourth one we have 6 blocks wide, so that's 4 plus 2. So in the 50th figure, we're going to have 50 plus 2 wide. So 50 by 52, our area is 2,600 blocks. So this lesson is all about recognizing patterns and drawing conclusions from those patterns. So inductive reasoning is one of our key vocab terms, and it's about observing data, recognizing patterns, and making generalizations. Observing data, recognizing patterns, and making generalizations about those patterns. The next key term we have is conjecture, and that's, while using inductive reasoning, the generalization that we make. So a conjecture is the generalization made from using inductive reasoning. So in this next example, we're going to see if we can make a conjecture about this experiment. So it says a scientist dips a platinum wire into a solution containing sodium chloride, or NaCl, sodium chloride, and passes the wire over a flame and observes that it produces an orange-yellow flame. She does this with many other solutions that contain salt, or sodium chloride, finding that they all produce an orange-yellow flame. So let's make a conjecture based on her findings. So what do we know about a salt solution and the flame that it produces? So she tried it. There were no counterexamples. Every single solution she tried that contained salt, when she put it over the flame, it produced an orange-yellow flame. So we can say, based on the evidence that we have so far, our conjecture is, if a solution contains salt, then in a flame test, it will produce an orange-yellow flame. So far, with the information we have, this has always been true. So this is a conjecture. It doesn't mean that it always will be true. It means so far we haven't found any counterexamples. Now, we haven't actually proved it yet, but we haven't found any counterexamples, so it's called a conjecture. Not quite a theorem, but a conjecture. So in this next example, we can use inductive reasoning to find the next terms in a sequence, or sometimes we'll use visuals and indicate the next visual in the sequence. But here we're just looking at a few numbers, and we are to make a conjecture about the rule for generating the sequence and then find the next three terms. So what do we first know about 2, 4, 7, and 11? So you might first start by multiplying the previous term by 2. 2 times 2 is 4, but 4 times 2 is not 7. So that's not our pattern. Maybe second, you look at adding. Let's add 2, for example. 2 plus 2 is 4, but 4 plus 2 is not 6. It's 7. So what do we have to add to 4? So 2 plus 2 is 4. 4 plus 3 is 7. 7 plus 4 is 11. So let's make a conjecture about our sequence and then the next few terms. So in 2 to 4, we add 2. In 4 to 7, we add 3. 7 to 11, we add 4. So how do we get from 11 to the next term? We would add 5. So 11 plus 5 is 16. Then, how do we get to the next term after 16? We would have to add 6. And we would get 22. Then, from 22, we would have to add 7. And that would give us 29. So like in the sodium chloride and the flame example, try this next one and make a conjecture and write down your conjecture on your note sheet. So take a minute, do this one on your own. Please pause the video while you work through the problem and then unpause for the solution. In this example, Sean draws these geometric figures on paper. His sister Courtney measures each angle with a protractor. They add the measures of each pair of angles to form a conjecture. Write their conjecture. So what do all three of these have in common? Well, they each start with a line. Here's a line. Here's a line. And here's a line. And then Sean also, in addition to his line, draws a ray that intersects with the line. Here's a ray, here's a ray, and here's a ray. Then they add them up. 90 plus 90 is 180. 50 plus 30, 150 plus 30 is 180. And 45 plus 135 is 180. So they all add up to 180 degrees. So their conjecture that they would have found was that if two angles are formed by a line and a ray, their measures add up to 180. Degrees. This is a degree sign. So we already know a couple things about two angles that add up to 180. So we could also say if two angles are formed by a line and a ray, then they are a linear pair or they are supplementary. On this next example that you have on your note sheet, look at these patterns of shapes. So here's the first term, or the first pattern in the sequence. Here's the second pattern, third pattern, fourth pattern, fifth pattern, and sixth pattern. So what do you notice about the first, third, and fifth shapes? They're all circles. So first of all, we know that they're all circles. What do we notice about the difference between the first, the third, and the fifth? The shaded area is always rotated 90 degrees or a quarter turn counterclockwise. So it goes from having the dark part here to the dark part here, then on the bottom. So what might our seventh shape look like? Well, we know it's going to be a circle because all of the odd ones are circles. And it's going to be shaded on the right half of the circle. Now, what about the second, fourth, and sixth shapes? Well, they're all polygons. And each polygon between the previous polygon adds two more sides. So in the second shape, we have a triangle, which has 3 sides. The fourth shape, we have a pentagon, which has 5 sides. The sixth shape, we have a 7-sided figure, which is a heptagon. So what do you think about the 8th pattern in the sequence? How many sides is it going to have? So if shape 2 has 3 sides and shape 4 has 5 sides, and shape 6 has 7 sides, then shape 8 would have 9 sides. And I'm going to cheat and use my Nanagon figure. So the 8th shape would have 9 sides, but what else about the 8th shape? We've got 3 little circles. One at the top, which actually is going to be filled in. And then we've got 2 at the bottom that are not filled in. And it'll be a little smaller than that. They'll be the same size, but there are 2 at the bottom 2 vertices of the shape. It's a little hard to see, but this one is not dark. It should just be white in the middle. A little smaller. All right, so our 8th shape will look something like that. 9-sided figure with 3 circles, where the top one is filled in, it's darkened, and the bottom 2 are not. So those are the next 2 shapes in our sequence. Now use the patterns that we discovered to draw the 25th shape. Well, let's see, the first shape is a circle with the top half shaded in, and then the 9th shape would be the same thing. So after 8 shapes, it goes back to the original, the odd numbers go back to the original sequence. So the 9th one would be the same as the first. 8 shapes later would be the same as the first. So the 9th, the 17th, 8 shapes later is the 25th. So we would have our circle with the top half shaded in. And then lastly, describe the 30th shape in the sequence. You don't have to draw it, but what would it look like? How many sides would it have? So if the second one has 3 sides, the 4th one has 5 sides, the 6th one has 7 sides, the 8th one has 9 sides. The 30th one would have 31 sides, so we call that a 31gon. And then it'll also have a little dot circle at the top, and then in the bottom 2 vertices, circles that are not filled in. Now on your own, and please pause the video while you work, look for the next, it says 3, but let's do 2, since that's how many spaces I gave you. Find the next 2 terms of each sequence. So first think of how it goes from 1/6 to 1/3, and so on. So please pause the video while you work, and you can unpause for the solution. The first sequence, we have 1/6, 1/6, and then 2/6 is 1/3, and then 3/6 is 1/2, and 4/6 is 2/3. Our next term would be 5/6, and after that 6/6, which this is 1. So our next 2 terms will have 5/6 and 1. In the next one, we're adding 2, then we're adding 3, then we're adding 4, then we're adding 5, then we're adding 6. So our next term we need to add 7. So we'll get 28. And then we'll have to add 8 to get 36. In the third sequence, first we add 3, then we add 5, then we add 7, then we add 9, and then we add 11. So we need to add 13, and we'll get 49. And then we need to add 15 to get 64. And in the last one, we're multiplying by 2 here. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 34, 16 times 2 is 32, 32 times 2 is 64, and 64 times 2 is 128. So on your own, I want you to try the summarized question. Are all conjectures that arise from inductive reasoning true? Why or why not? So think of what a conjecture is. Remember that it only includes observable information and patterns that we see. And then in the next example, it says to use the rule of n squared minus 1 to generate the first 5 terms of the sequence. And then it asks, what's the 100th term? So the first term would be 1 squared minus 1, which would be 0. The second term would be 2 squared minus 1, which is 4 minus 1, which is 3. The third term is 3 squared minus 1, which is 8. 4 squared minus 1 is the fourth term. And then the fifth term is 5 squared minus 1. What's the 100th term? So on your own, calculate the 100th term. And then the last question is, if Mr. Ross leaves for work at 7 a.m. and is on time, use inductive reasoning, so again, the information that we have that we can observe, to make a conjecture about Mr. Ross. So what will be true, what will always be true, based on the information that we have. So we can say Mr. Ross will always be on time if he leaves at 7 o'clock a.m. Now, of course, there could be a counterexample, so we can't say that this is always going to be true, but based on the information we have so far, we have not found a counterexample. But at some point, maybe there's an accident on the way to work, or maybe there's a traffic jam, or maybe his car breaks down. So that's not always necessarily going to be true, but that's our conjecture based on the evidence that we have. Please jot down any questions you have throughout this video and bring them to class with you. Thanks, girls.